Chocolate below that way.
Solids generally expand when heated and contract when cooled. However, the rates at which they expand or contract differ. So if you look at iron and brass contract differently and also expand differently. However, both are metals. And for being metals, they are solids. So the rates at which iron expands differs from the rate at which brass expands. The same applies to contraction. So brass and iron have different rates of contraction. I hope what I'm saying is understood. Yes. So there are experiments to prove the fact that solids generally expand when heated and contract when cooled. One of the two experiments is the metal ball and the ring experiment. We have the metal ball and the metal ring experiment. We also have the metal bar and the metal gauge experiment. So these are some of the experiments to prove the fact that solids generally expand when heated and contract when cooled. I hope you can hear what I'm saying. Yes, sir. Now there are two experiments to validate the fact that solids, when heated, expand, and when cooled, contract. And what are the two experiments that we're going to use to prove that point? One, the metal ball and the socket experiment. And then two, the metal bar and the metal gauge experiment. So we'll take a look at the two experiments, one after the other. Is that understood? So here, this is a metal ball. A metal ball. And this is a metal ring or socket. Initially, this ball fits into this ring or socket. See the ball here? It's inside the socket. That's before heat is applied to it. But after being heated, it is discovered that it becomes very difficult to fit this into the socket again. I hope what I'm saying is understood. Why? Because the ball has very good. So it has expanded. So that expansion made it difficult for this ball to fit into the socket. Initially, it was able to fit into the socket, but now expansion has made this to become difficult to fit into the socket again. This is what heating does to a solid substance. So when it's applied to a solid material, the material expands. So this ball will expand. Initially it was fit into the socket, but now to fit it into the socket becomes difficult due to what? Expansion. But when allowed to cool, what is going to happen? The metal ball, which initially expanded, will contract, and once it contracts, it becomes very easy to fit this into the socket. I hope that is understood. Very good. So this is what is one of the experiments to buttress the fact that solids, when heated, expand, and when cooled, contract. So when heated, there was expansion, and that's why this ball cannot be fit into this. But when allowed to cool, so it becomes easy for one to fit the ball into this window. So this is called the metal ball and the metal ring experiment, as one of the experiments to show that solids, when heated, expand, and when cooled, contract. So this is one of the experiments. The other experiment is the metal bar and the metal gauge experiment. So here we have something similar to this, but the diagrams are not the same anyway. So we have this.
Shut up. I said, it's very good sense. They're not. So then just do this. I go start this again.
So here, this is the metal bar. So here is the bar. This is the bar, the metal bar. And this is the metal gauge. The metal bar and then the metal gauge. Initially, this bar can be made to stay in this gauge. Just push it in with little force. What happens? The bar stays in the gauge. That's before heating is done. So once heat is applied to this metal bar, it will expand. And once it expands, that means the length will increase. So if the length is 8, let's say 8 centimeter, possibly the length will become 12 centimeter. You can see that the bar, okay, has a 4 centimeter extension due to the application of what? Of heat. So the expansion is now 4 centimeter. So from 8 now to 12 centimeter. So it becomes difficult for one to push or fit this bar into this gauge because of expansion. Why did it expand? It was able to expand due to the application of heat, which also compresses the fact that I talked about from the beginning, that when solids are heated, they expand. So what would you do? Allow it to cool. Let there be a drop in its temperature. After some time, once it's allowed to cool, what happens? This bar, okay, will what? Contract. By contraction, it is assumed that it will take its original shape. And what happens? It becomes very easy for one to push it with little effort into this metal gauge. Again, this shows the fact that when a solid material is heated, it expands. And when allowed to cool, it contracts. I hope what I have explained so far is fully understood. That's it. So there are different effects of expansion. Effects of expansion of solids. So one of the effects of expansion of solid is seen in buildings. What do I mean by buildings? For buildings whose roofs are made of galvanized iron sheets. On a hot sunny afternoon, creaking noise will be heard if you are inside that house that has a roof made of galvanized iron sheets. Creaking noise will be heard due to what? Expansion. I hope what I'm saying is understood. Expansion of the roofing sheet causes that sound which will be heard by anybody inside that building. I hope what I have said is understood. So creaking noise heard inside a building whose roof is made of galvanized iron sheet on a hot sunny afternoon. So this is as a result of expansion. So the roofing sheet tends to expand as heat from the sun falls on it. I hope that is understood. So it receives heat from the sun. That heat from the sun makes it to expand. And as it expands, sound is being made. And that's the sound that anybody who stays under that roof hears. So this is one of the effects of expansion of solid. Is that understood? Yes. So this is one of the effects of expansion of solid. So on your own, which other one can you think of as one of the effects of expansion? One of the effects of expansion. One of the effects of expansion. Now we said creaking noise being heard, right? Yes, sir. How is everything?